let's build something. It's ages since I built a project, and I saw these clocks for sale on AliExpress. And what really appealed about them is the fact there's no microcontroller. It's based on discrete CMOS logic. And I had a look around and I found a schematic and very quick summary of the schematic. 4060 binary counter with the oscillator built in with a 32.768 kilohertz crystal, divides it down, another divider stage, and then it's got these dual binary counters, each feeding a converter that converts the BCD, binary coded decimal, to a 7-segment display. And it's really neat because they've got a bit of logic here and it's really minimalist. It's great. That when it rolls over from 59 to 60 seconds, that's the only point that two of the binary outputs become high. And this is an AND gate. And when it does that, it resets it so it rolls very briefly over to 60 and then clicks back to 0, but also sends a pulse to the minutes that then increments the minutes. And it does the same for the hours. Very neat indeed. So let's build it. The one I'm choosing to build is the green one. The reason I'm building the green one is because it's got slightly bigger pads, I think. I mean, there's no major difference. I'll probably end up building both. But what I'm going to do, I'm going to put little header sockets for the LED displays so that I can get other ones, like these for instance, but with the correct common cathode and not the common anode like the ones I ordered. Common cathode, they sent common anode, which is quite annoying. But it means you could then plug in new LED displays if the other one's faded, or you could just choose different colours: white, blue, red, green, anything you wanted. So this kit comes with everything stuffed in foam, which is not really what you normally do with CMOS. This one comes with them just rattling loose in a plastic tub, which is also not what you do with CMOS. You're supposed to protect it from static discharge. But that doesn't matter. I'll put this to the side. If the chips are dead or damaged, they're easy enough to get replacements and change them. It's very, very serviceable. So here's what I'm going to do first. Let's zoom down this. What I'm going to do first is populate all these resistors. The components you do first are the smallest ones. So I'm putting all these 510 ohm resistors in. And then I'll be putting the other resistors on the board and the diodes that are used to basically steer logic. What are they used for again, the diodes? Oh yeah, it's so that you can increment it with the buttons. It's got a couple of buttons here, and it's so that they can feed input gates as well as the reset from the previous chip or that's used to increment the next digit. It just lets it, it's just crude logic with diodes. So I'm going to start off by getting the components out, just pour them all out. And I'm going to start forming these resistors and putting them in. And I'm going to pause while I do that because it's going to be quite time consuming, though I will note that because of the size of the circuit board, they've literally just folded leads right up tight against the components. That is the correct spacing. It's not the best way to do things, but it's okay. Also, these are these horrible blue metal film resistors, which makes them just so hard to read. But that is irrelevant here because the huge number is for the LED displays, and then there's only a few different values for all the other functions. So I shall put them in this position now, and I'll be back in a moment. One moment, please. So that's the first row of resistors in. I've put a bit of masking tape over them. Very tempted to put them into my assembly jig, but that wouldn't be fair because not everybody has an assembly jig. So this is the next best thing. It's just using sticky tape to put components in one section at a time. So I'm going to start soldering these, and I won't necessarily torch you by showing the whole soldering process. So as with usual soldering, you don't carry solder to the solder joint. You apply the soldering iron to the lead and the pad simultaneously and then add a bit of solder into the mix. And because these leads are in the close vicinity, it's actually a wee bit irksome to get access. I did leave them quite long, but having said that, it was easier putting them in with that length. I'm only going to solder one side. Then I'm going to take the tape off and make sure everything's seated correctly, just in case I put any in wonky before I solder the other side. But it is soldering relatively easily, which is nice. I noticed the other one, the black circuit board, it has smaller pads. I mean, they don't need to be smaller. There's space for bigger pads, but they've chosen to use smaller pads, and it just makes things a little bit harder to solder. So tell you what, I shall pause while I solder the rest of this row. 1 moment, please. Okay, that's one end of the leads soldered in. So before I solder the other ones, I'm going to crop these leads because it will make it much easier for access. It is irksome, to say the least, having them all so close. And there's a lot of resistors. Am I right in saying that these magnetic? That would be so annoying if they'd got magnetic. They inevitably do. It's what happens. Fortunately, by that time, they've gone a bit blunt, particularly when you abuse them and you cut far too big of things with them. The soldering joints are not a very consistent size here. Why is that one not even cutting on? It's because exactly as I say with the soldering joint not being a consistent size. Just because they are tiny pads, it just makes it that little bit hard to control the flow of solder. Having said that, am I using quite a big chunky soldering iron bit, as I usually do, just because I prefer the big bits that just smash some heat in very quickly, compensating for my impatience. So now I've cropped those leads off, I shall just brush them up to the back there. This is going to be much better for access. I'll just remove that lead that I've dropped across pads. And now I can get on with soldering the other leads. I can even pick it up if I wish. Maybe not the best thing to do. Actually, it's not bad for the multi-finger soldering techniques. So the script is the same. I shall keep going and solder these leads, and I'll join you again in a moment. Okay, so far so good. That's them soldered in, looking fairly neat, and the leads at the back have been cropped. There's a couple of spare resistors supplied because they're cutting off probably by weight or distance more than actually counting the resistors. We have a couple more resistors that have to go in here for the fast blinking LEDs. So I shall fold the leads and pop them in and solder them individually. And to be honest, at this point, it's going to be all the other resistors and diodes. So I'll just hold that in with a finger and solder one lead. It's going to be much easier soldering them now because there are just a few and you can solder them individually instead of like putting rows of them in and then bits of sticky tape to hold them in place. But the sticky tape is a big time saver for when you are soldering a huge row of resistors like that. It means you can just basically just munch along them all with the soldering iron. Not actually munching the solder though, because it's toxic, because it's super duper lead based. That's what I'm using here, lead based solder. I do recommend it for projects, personal projects. It just flows better. I know a lot of people say, no, I'm using lead free solder and it's wonderful. Well, I'm not. So next down here, we've got 4 resistors of an equal value. What is that equal value? Yellow, violet, black, and then it could be anything. Brown, so that's 470, and then one other 4.7K. 4.7K. Okay, so we have one there, one there, one there, and probably one somewhere else, or maybe they've provided spares. Okay, right, so let's just crop those free. When I've got resistors and bandoliers like this, I tend to just cut them off like this. Take a pair of scissors. As you can see, I've abused these scissors and they don't close properly. But it's just the easiest way to get them off bandoliers. And just because, for no good reason at all, I'm putting these resistors in the direction that matches the text in the board. It is interesting to note that this circuit board does have the component values actually marked on it as component values, which is nice when they do that. It means you have to be very confident about your design, because otherwise, if you change something in design at a later date, then the component markings are wrong. So I think that's a spare resistor I've got there. But I'll find out in a moment when I find a spare place for it on the circuit board. It's nice when they supply spare components though, because sometimes they drop into the carpet or ping across the room. So I'm just I'm holding it against my tummy here at the moment, just to get the first solder on. because I'm trying to hold two resistors in at once because one was wanting to drop out. So I'll just solder that other lead there. And then go along and solder this one as well, which was holding in slightly better of its own accord. That's that. Are they nice and flush and flat and nice looking? Yes, they are. Okay, let's solder the next connection on them. And then we'll look and see what's next. I think the diodes might be next. There are some capacitors to go on as well. Oh, and there's a couple more resistors. Super high value resistor. Because for some reason the clock oscillator, as shown in this picture here, it's got a 100k and 10 megohm loading resistor. 10 megohm loading resistor for the crystal to kind of provide stability, I guess. Or are those resistors getting roughly in the ballpark frequency and then it's being done, the rest of it is being done by the crystal? Oh, there's also lots of tiny capacitors. Excellent. Now, what do we have here? We've got two resistors. One is going to be a 100k and the other is going to have a stupidly high value. So this is brown, black, black, green. That is 100 and 50. So that'll be the super high value one. And it's going over in the sort of like the oscillator section next to the crystal. There it is. 10 megohm. 10 megohm resistor. Another thing, I'm leaving the lead full length this time, mainly because I just didn't crop it. What you can do when you're putting these in is you can put a slight kink, but I don't recommend kinking them right against the circuit board. But this will stop them dropping out and going wayward. So this one should be about 100k, which is brown, black, black, orange, which is 1003, which is 100k. Excellent. I'm glad everything is working out nice. I will run out of things to say at some point in time. This is why I should have done a questions and answers. Usually when I do that though, I don't get through a huge number of the questions because I tend to get distracted at tangents while I'm doing it. So that's that connection there, and that connection there. Ow, ow, hot. And I've just blocked a pad, I think. Yes, I have. I've just filled an adjacent pad because it was very close. Not to worry, I can soon do something about that. Bit of desoldering wick will suck the solder out of that. It's one of the crystal holes. So I shall crop those leads. Now, is that pad connected by a... It is connected by a track. That's why it was so receptive to solder and it flowed onto it. Using a huge bit was probably not in my favour at that point in time. Where is my desoldering wick? Where is my desoldering wick? It was right next to the bench, and now I don't see it because I've shuffled stuff. 1 moment, please. Let's see if I can make a huge mess of desoldering this hole here, clearing out this hole. This is where I hate double-sided boards, or worse still, multi-layer boards, for the fact that it's so hard to get the solder out of them. I could have just done the bang it on the table thing. But I shall try and suck the solder out with the wick. Yeah, it didn't work. Tiny hole, full of solder. I'm going to try the bang it on the table type trick. I'm doing that silly thing where on the gadget mountain, at the side of my bench here, I'm putting things in plastic bags. And you know how slippery they are? They just basically just slide everywhere. I may have to resort to a desoldering pump on this. Let's try heating that up and then tapping it. No, that didn't work. Oh, these tiny holes. 1 moment, please. Desoldering pump did it. I should have actually started there, but I didn't want to make a dick of myself, as sometimes happens. This is a little engineer desoldering pump with a bit of silicone sleeving at the tip. It's actually okay. Right, what's next? Capacitors and the crystal and the diodes. I've got little diodes. I'll put the diodes in next. They're 1N4148, which is an absolutely generic diode. They've provided 4 of them. How many are in the circuit? 1, 2, 3, 4. Oh, there are 4 in the circuit, if that drawing is correct. Oh, there they all are there. Okie dokie. Now, are these going to be... These aren't going to be folded straight next to it. So I could do the little lead forming tool. I'm going to have to pause while I find one of those. Oh, no, I found it. Is that going to do it? Because there's no spares, I can't really test that. Hopefully this is all in focus. It's so hard to see because I've got a very small screen to work with, and sometimes things get focused on, then it doesn't get changed afterwards. So let's just check the diodes. I think that stands a good chance of being the right spacing. Watch this, it won't be. 1. Oh. Very fumblesome, yes. Well, that's the smallest setting, so if it's no, it's actually smaller than that. That's not great. Right, that's very annoying. Tell you what if I just mush them in my fingers to put them in? Noting that these are polarized, is that going to work better? Or have they just chosen a very odd size? Yeah, just mushing it in your fingers works fine. Okay, mushing it is. This one is unmushable. I might just go and grab another diode for that. Make sure I'm putting them in the right way around. There is a little band that shows where the dark band is supposed to go at one end of these diode packages. Am I wandering off shot as well? Just a little bit, probably. In goes that diode. And another, just grab the package and fold the leads round, and apparently that just ends up about right. That's not up to military specification. People will always complain about that. They'll say, you're doing it wrong, that stresses the leads and the components and things like that. Where it bends, you're not supposed to bend it too close to the component, but that might be old era components. The modern ones are fairly robust. Is this going to go in? Now I've reshaped it. Yes, it is. Now, if I tip this up, are these just going to drop straight out again? No, they're not. That's good. Soldering. As always, if you get bored, you can skip forward. That's the joy of YouTube. Or if you want to skip forward to where it's actually in focus, that could also be a thing. It's not the greatest thing. The camera is mounted at a fixed height, and if I zoom too much, it just becomes a bit grainy. The garage workshop area has a very useful camera mount that can be mounted up, moved up and down. It's all custom made, 3D printed and made with shelving brackets. It works quite well, holds pretty robustly as well. So far, it's been okay. But as with everything new, I've got that new studio setup out there, and it takes a while to get into the swing of using a new studio area or new equipment. It is designed for bigger things, but that said, a lot of the things I've been looking at out there are too big for it too. They're just so huge. Crop, 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 crop 2 at once. And crop. They're all soldered. Good. Little splash of solder on the circuit board there. It doesn't really matter. Right, tell you what then. What is next? We've got dinky little capacitors here. 2 values probably, I would guess. We've got the load capacitors. They're 30 picofarad for the crystals, but we've also got the debouncing capacitors of 10 nanofarad. So I'll have to make sure I get those right. Don't mix them up. There may be 2 that are specific size. These ones are bigger. That's 22. Oh, these are marked 22, aren't they? Yeah, so the big ones are the lowest value. So they go in here. Very, very fumbly. I shall solder that. I'm not going to push it all the way down because I can already feel the slight stress in the leads pushing that in. And I shall solder one of the leads. These are these tiny little ceramic capacitors that when you solder them, they go shiny. Well, they used to anyway. because it's almost like a wax comes out of them. I think they're wax dipped to stop moisture penetrating into them. So I've soldered one lead of that one. I'll just solder the other lead. Ramble, ramble, ramble. I don't know if you're seeing an awful lot here. Just pretend you are. It really needs super duper microscope, dedicated bench, and when you do that, it just means it's actually quite hard to do the task. So I shall put this little capacitor in. There's going to be a slight delay in this project for me, but you won't see it. You'll see the clock working at the end of this video, hopefully. Because I've had to order some Turnpin sockets, so I can change the LED displays just by plugging new ones in. But unfortunately, when I went to my component drawers, I thought I had some, but didn't. So I've ordered some off eBay, because it's going to be the fastest. It's a UK seller. So this is 103, which is 10 nanofarad, because it's 10,000 picofarad. And these are going in the vicinity of the switches. It's marked 0.01 microfarad. So I'll just solder them in one at a time. I should check this is in focus. What's the bet that I just knocked it out of focus? I'm going to zoom down, see, no, that looks pretty sharp. Actually, I might just leave it there. I might just leave it there because that is easier to see. Right, so I shall just solder this lead, wobble, wobble. Make sure it's square. It is. And then solder the other lead. This is where it does go out of focus now. It's inevitable. Making videos involving detailed work is harder than you might think. If you have autofocus in the camera, it will always focus on the wrong thing. That's just because, you know, it's not capable of differentiating. The cameras are not designed for YouTube videos at a bench. They're designed for filming people, and it tends to just treat it as a sort of background, sort of general sort of image, and just gets confused. Well, it gets confused. Even Abe's camera always gets confused. I usually lock the focus in mine, just so it doesn't do anything fancy itself unexpectedly. Although having said that, the Moto phones that I tried, they were not suitable for bench filming because they would just basically, they'd pretend they were focusing and then they'd just not focus quite on it, and then you'd review the footage and it would be all out of focus. That was so annoying. I'm looking for the next capacitor. There it is over there. I know what that one is. That's the one associated with the little switch. So a lot of these little capacitors are for what they call debouncing. When a contact closes, it doesn't just close decisively. The speed we're talking about here, the circuitry here can see a contact physically bouncing up and down as it comes to a rest. It's called contact bounce. You don't see it, you don't hear it, you couldn't see it with the naked eye, but the circuitry can see it. And what happens is, because this is counting numbers round to set the time, clicking that button without the debounce, it would just shoot random number. It might go up a single digit, it might go up 3 digits, it might just keep going random numbers. That's those capacitors in. The next things to go in are going to be, well, the crystal. I'll put the crystal in. Where is the crystal? There it is. It's a little clock crystal. A very classic 32.768 kilohertz, because it just is a very common choice of frequency, because it's a nice divider with binary down to 1 hertz. You'll find it in a lot of timing systems. You'll find it in quartz clocks. You'll find it in watches. Just everything. Somewhere in China there are factories that just make nothing but 32.768 kilohertz crystals. And the good ones go to their best customers, and the crap ones go to us via eBay. I'm just going to wipe the tip here. Just the tip. Oh, I'm going to actually come onto shot as well. Okay, that's the crystal soldered on. Now come the sockets, and I'll do one socket, but I won't torture you by showing all the sockets being soldered on. We've got a nice row of solid sockets here. I would love to have used Turnpin sockets in these, but that's not practical because I don't have any. So these are 16-pin sockets. And the way I like to put a socket in, I like to pop it through, making sure you get the little indent at the right end, because that's useful for remembering where to put the chips in, which way round they go. I like to solder a pin at diagonally opposing corners, like this. And then I'll just check it's sitting flat. And if it's not sitting flat, then you can put a bit of pressure into it and you can reflow it, and it will sit flat. And after that, once you've done that, the chip is locked in place, and then you can just go along soldering. And this is actually getting a bit fumbly. They've saved space in this circuit board by mounting things quite close together, which is reasonable enough. It's probably what I'd do as well. But it just makes that a little bit harder for soldering. I'll try and stay in shot. I'm zoomed in far too much, haven't I? Right, well you've got the gist of the socket soldering, so I'll come back once I've soldered them all in. One moment, please. Oops, I was so engrossed I completely forgot to start filming again. I have added the little clicky buttons in and the capacitor. Now I've got the switch. The little switch is the one that turns on the clock, turns it on or off, not the actual like turning on and off the clock display, but actually physically turning on the clock signal, the actual 1 hertz signal that clocks the whole numerical system. So this little switch here, it's quite wobbly. It's not easy to put in, so I'm going to solder the middle pin. I'm just going to check if it's level. Oh, it is level, that's all right. If it wasn't level, I'd simply nudge it slightly while reflowing the solder in that pin, but that looks okay. So I shall solder the other 2 pins, and maybe, because I only put a wee dab on that little tack, I'll just put another little blob there. And now we've got the power connector that I can put here. I've got a better power connection than this, but this will do. It's nothing. It's not fancy. I'm just going to be sticking a USB cable onto it anyway. So I shall just hold that flush with my finger at the back, solder one lead, let it cool. That looks lovely, and solder the other one. And at this point, there's a huge delay for me, but no delay at all for you, because I'm waiting on the little sockets, the socket strips I want for these LEDs, so I can just swap the 7-segment displays in different positions. So before I solder, before I put the integrated circuits in, I want to put those sockets in first and the LED displays, and the chips will go in last. And I've got my lead former for the chips on standby. That's assuming the chips have survived being stuffed into ordinary plastic, which isn't ideal. But that's the progress so far. This will literally be 1 moment please for you, but slightly longer for me. So 1 moment please. The Turnpin contacts have arrived, so we can proceed with this project. Excellent. If you wonder why I've got a glove on, it's because I've taken an allergic reaction to something, and I'm not sure what it is. I'm just protecting the hand at the moment from that. So here are the Turnpin strips. Now, it would have been, I'll zoom down a bit. The idea here is that I've broken them into sections and mounted them onto the LED displays. And now when I put them into the circuit board and solder it, I'll be able to unplug the displays. And later on, when the correct ones arrive, if they arrive in time for the end of this video, it would be great. But when they arrive, I can just simply plug the new displays in. It makes it a serviceable clock. Say, for instance, you wanted white displays, but you didn't want the unreliability of the white LEDs that fade over time. You could just plug in new displays when you felt it needed a refresh. Now, the reason for the Turnpin contacts versus the usual flat pin contacts is because the ones that are designed for square pins have a knife type system contact that slides onto the square pin and it needs the square surface. If you try and use them on, say for instance, a round surface, they may just not quite make contact, or they'll just slide off to the side, and it results in an intermittent connection. So turned pin is best for that. And it's very easy with these ones just to snap the number pins you want off. He said, snapping, let's try that again. The gloves are not helping here, but you can snap them off in multiples of the size you want, in this case 5s, and that just makes it a very versatile connector. It also makes an excellent connection, as I mentioned. It's useful for many things. So here is one of the displays, and I'm just going to make sure the pins are aligned and clean, because I see a little bit of foam on that. So align the pins up, and then slide this over, and this is where I will screw it up. There it goes. And this one as well. Slotted on. So I shall do that with the remaining displays, and then I'll solder them in. Then I've got a decision. What height do I mount the LEDs? Because if I put these in now, they're going to be standing a little bit higher than they did before. I'm kind of thinking that the LEDs are so annoying, I may just leave them recessed straight back, or I could put in a pair of pins and then you could swap LEDs as desired. But I'm thinking really I'll probably just recess the LEDs in. Not sure, I've not made my mind up about that yet, but I shall start by putting these LED display sockets in. One moment please. The displays are in and it's looking more clockish now, so that just means that it's time to put the integrated circuits in. So I shall put one or two of these in. Let's see, where's my favourite one, the 4060? There it is. So the 4060 is the actual time reference. Now, somebody mentioned, I mentioned I was halfway through this video on a live stream on Twitch, and someone mentioned that there's no decoupling capacitor on this at all, and there aren't. There should be decoupling capacitors somewhere on the supply line, so that could potentially lead to instability of this. But anyway, the chip numbers are marked right next to the sockets. I've just put my leads into the alignment tool. If you don't have one of those, it's fine. You can usually just carefully mush them in. Making sure the indent at pin one end is aligned correctly with the socket and push it in. It would have been nice to change these all to turn pin sockets, but it's a bit late for that. What else do we have? What is the next chip here? There's another thing I'm thinking here. There's a 4013. That's this chip down here, which is used to extend the binary counter in this by one stage, but they've only used one half of it. I didn't check if they've actually tied the input pins solidly to a rail for stability. Also, they could have used that other one as a buffer, or even as a divider again, to actually make these LEDs flash at half the speed. Just things that they could have done. Let's put the IC in here. Pop it into its socket. Is that the only 14-pin chip? I think it is. Okay, well, you've got the gist. I shall plug the other chips in, but I won't power it up until we're recording again. One moment, please. And the last chip going in. Making sure you align the leads up properly, because if you don't, and you squish the chip in, the leads can fold underneath. Rightio, the chips that should have been in anti-static foam, but they didn't. Even if you put a bit of tin foil across, that's what Maplin used to do, and supply the chips pushed into ordinary foam, but with tin foil over it to short all the pins together. Not sure if that was a good thing or not. Okay, right. Is this going to be a disaster? An educational disaster? Let me just focus down onto this. I will bring in a USB power supply. Just double checking. And plug it in. That's a good start. Not bad. So to set the time, you can press this button and it will increment the numbers. So hold on, I'm just going to stop the clock. with this switch. Oh, I'll tell you what, it stops the clock, but it doesn't stop the LEDs in the middle. But it lets you stop at a very precise time. Okay, what is the time? Is it displayed on this device? No, it's not. Hold on, let me grab a neighbouring phone. Oh, it's 00:54 AM. So I've stopped the clock, so I can put this round to 54, noting that if I overrun, it would increment the next counter. Do you want to see the proof of that? 1, 2, 3, 4, 5, 6. It did increment it. So let's go, and it won't fast forward because there's no microcontroller, so I'm going to have to push the button all these times. Might as well just push both then. So 54, it's probably 55 now, and that's going to be 0. And then when we're ready, flick the switch and the clock starts. Not bad, not bad at all. I've not done my usual thing there either. See these little plastic films over the front? They're part of the manufacturing process. They're not to protect it, but when you remove them, it gives it a nice matte finish underneath. But you have to be careful in removing it not to chip the black surface. Anyway, I'll do that afterwards. I'll change the lighting so you can marvel at this clock in its full digital glory. And there you go, not bad. This is the type of clock that gets small school children arrested for making bombs in America. This has no bomb functionality, incidentally. I should mention that. It doesn't really have an easy facility to do that. I mean, obviously, if you had electronic knowledge, yes, you could. But it's lovely that there's no microcontroller involved in this. I wonder how accurate it is. One way to test that would be to get an accurate frequency meter and put it onto the 4060, which is a binary counter chip, and the binary divider and oscillator, and go one stage beyond the oscillator to buffer it so it didn't affect the oscillator's frequency, and then you could get a fairly accurate frequency. That would be 32.768 kilohertz divided by 2, so it would be 32.768 kilohertz divided by 2 equals 16.384 kilohertz. It would be a good reference frequency. But there we have it. Now, this is where it gets awkward. Watch your eyes, the light is coming back. The light is back. Now, by awkward, I mean I'd love to show you it with the new green displays in it, but I don't know if they're going to arrive in time before I travel with work. But so if the video ends now, that means they didn't arrive. If you see all the little things, the suggested videos popping up. But if they've not popped up so far, that's good, because it probably means that there's another bit to this video and you're going to see the other displays, assuming they're the correct polarity. Until then, that's this kit build complete. And in a rare twist of luck, the new LED displays have arrived literally hours before I leave. So let's swap some in and see how they look. So this can be done while it's running. I have done some tests on the timing. I've had plenty of time to do that. Oh, these are a bit mashed. That's not so great. That's fine. But I've had a chance to test them while it's been running, and it's gaining not quite a second every day, and that's very easy to adjust. So every few days you could just basically turn the switch off to stop it counting, and then on again. It would actually be back in sync. But let's see if I can swap these in, since they are in the sockets. This could be a bit fumbly. So I'll just try and stuff that in there. A lot brighter for a start. Oh, those pins are needing aligned. I may have to pause while I align the pins, because it could take a moment to put these in. I shall pause. 1 moment, please. And the deed has been done. The displays have been changed, but the colons have been left red. There is a reason for that. The two LEDs are in series, so it has to be low voltage LEDs. You could theoretically use gallium phosphide green LEDs for those, though, because you don't want them to be too bright anyway. But there we have it. It's a nice enough clock kit. It's fairly straightforward to assemble. It's actually quite accurate, and it's neat. It's quite enjoyable to build. And it looks good, and of course, if you put the sockets in, you can maintain it in the future. You can actually change displays. So I'd say that's a win. That was quite fun to build, and you've ended up with a very functional and serviceable clock.